Hello everyone. My name is Rojin Belgane from Frontier Laboratories. Thank you for joining us today to learn about our rapid catalyst screening systems. In today's short webinar, we will discuss the Tandem µ-Reactor GCMS technique and how this system operates. As we all know, catalysts are very important materials. Many researchers and testing laboratories are exploring new and more effective catalysts. Catalyst scientists must evaluate and identify the effects of various parameters on the performance of a catalyst before incorporating the catalyst into large-scale installations. So a technique that can rapidly characterize the performance of a new catalyst is of great interest to scientists and process engineers. However, the traditional catalyst evaluation systems are large furnaces with a startup time of about 3 to 5 hours for stabilization. Therefore, a catalyst evaluation normally requires a week to several weeks. So, to enable the rapid characterization of catalysts, Frontier Laboratories developed two types of rapid catalyst screening reactors: Tandem µ-Reactor and single µ-Reactor, and they're both based on a microfurnace technology. These reactors are directly interfaced with your GCMS systems, allowing real-time monitoring of the chemical species generated by vapor phase contact reaction with a catalyst. Besides the ability to screen the catalyst rapidly, the microfurnace technology operates with precise temperature control, quickly heats and cools, and has a simple design for scientists in terms of operating and maintaining the system. Analyzing the transformed product is another competitive advantage of microreactors. Online real-time monitoring and separation analysis can be done, while multiple temperature zones can be automatically and individually analyzed. In our today's webinar, we will mainly focus on our Tandem µ-Reactor, which enables the rapid catalyst evaluation for all kinds of samples: gases, liquids, and solids. Here you can see the system diagram of a Tandem µ-Reactor. A Tandem µ-Reactor consists of two reactors connected in series. The first reactor preheats a gaseous sample, vaporizes a liquid sample, or pyrolyzes a solid sample. The volatiles then exit the first reactor and flow into the second reactor. The reaction temperature controller controls the heating and cooling of the reactors. It has a switching valve and flow controller, so one of the three reaction gases can be introduced during the testing. The second reactor has a quick change catalyst reaction tube where its temperature can be programmed through various heating modes such as isothermal, linear, and stepwise temperature programs. This figure overviews a rapid catalyst evaluation system with a Tandem µ-Reactor and mass spectrometer. In the Tandem µ-Reactor, the two reactors are individually temperature controlled. Volatiles released from the heated or thermally decomposed sample stream flow into the catalyst reaction tube in the second reactor. Then the products form flow into the GC for analysis. The catalyst is evaluated by noting what compounds are found and their relative distribution using the mass spectrometer. The Tandem µ-Reactor can also be used in three different modes. These modes differ in how the reactor temperature is controlled. The isothermal mode has a post-heat function to thermally desorb reaction products in the micropores of various types of catalysts. The Tandem µ-Reactor temperature can also be programmed in either a linear or a stepwise progression up to a maximum of 8 steps. When used with the selective sampler and microjet cryotrap accessories, a maximum of 8 temperature zones can be automatically and individually analyzed. Also here you can see that both online monitoring and separation analysis can be performed using the Tandem µ-Reactor. The real-time MS monitoring uses an EGA tube. An EGA tube is a short and deactivated tube. To switch from real-time monitoring using an EGA tube to the GCMS analysis using a GC separation column, You simply use your vent-free GCMS adapter to switch the EGA tube and GC separation column without venting your MS. Lastly, you can see how the catalyst reaction tube is packed with a catalyst. Small amounts of quartz wool are placed at the bottom and top of the catalyst bed to keep it in position. The usable vertical length of the catalyst bed is 40 millimeters. Catalysts with a particle size of 20 to 60 mesh are used. The catalyst reaction tubes are typically used. However, if a larger catalyst volume is required for testing, the deactivated stainless steel tube can also be packed. Exchanging the catalyst tube is very easy and quick. You first remove the first reactor, then lift the catalyst tube from the top of the second reactor, and that's it. With that, we would like to thank you for your time and for attending this short webinar about our tandem microreactor system today.